In today's competitive manufacturing landscape, the difference between thriving and merely surviving lies in one critical discipline: industrial engineering, the science of eliminating waste and maximizing productivity. Welcome to the complete Industrial Engineering and Productivity Masterclass, your comprehensive guide to transforming manufacturing operations. Over the next few minutes, we'll master 8 critical areas: industrial engineering fundamentals, work measurement, method study, productivity enhancement, incentive schemes, job evaluation, performance appraisal, and practical problem solving. These principles apply across all manufacturing sectors, from automotive to pharmaceuticals, electronics to food processing. By the end of this masterclass, you'll have the tools to systematically improve any manufacturing operation. Industrial engineering is the branch of engineering concerned with designing, improving, and installing integrated systems of people, materials, information, equipment, and energy. While mechanical or electrical engineers design products, industrial engineers design the processes and systems that create those products. We are the engineers of efficiency, productivity, and quality. Our discipline was founded by pioneers like Frederick W. Taylor, the father of scientific management, and Frank and Lillian Gilbreth, who pioneered motion study. Industrial engineering's primary objective is eliminating waste, or muda in Japanese. There are 8 critical types of waste. First, defects, the production of non-conforming parts or services that require rework or disposal. Second, overproduction, producing more than is currently needed, tying up capital and space. Third, waiting, idle time for people, information, or materials that adds no value. Fourth, non-utilized talent, failing to leverage the full skills and knowledge of your workforce. Fifth, transportation, unnecessary movement of materials or information across your facility. Sixth, inventory, excess stock that ties up working capital and masks other problems. Seventh, motion, unnecessary movement of people that waste time and energy. Eighth, extra processing, performing work that adds no value from the customer's perspective. Industrial engineering has 5 core objectives. First, productivity improvement, systematically increasing the ratio of output to input. Second, cost reduction, methodically analyzing operations to eliminate non-value-adding costs while maintaining quality. Third, quality assurance, designing processes that consistently produce high-quality output, focusing on prevention rather than detection. Fourth, human factors and ergonomics, ensuring systems are safe, comfortable, and efficient for human operators. Fifth, operational efficiency, ensuring smooth, streamlined flow throughout the entire value chain. Work measurement is the systematic application of techniques to establish the time required for a qualified worker to complete a specified job. Its purpose is to determine standard time, not just an average of past performance, but a scientifically determined benchmark. Standard time includes the core work elements, adjusted for operator pace, plus allowances for personal needs, fatigue, and unavoidable delays. Time study, or stopwatch time study, is the most direct work measurement technique. Let's walk through the formal procedure. Step 1. Select the task to be studied, prioritizing repetitive operations with significant cost or output impact. Step 2. Break down the task into fundamental, observable elements that can be consistently timed. Step 3. Observe and time a qualified operator over sufficient cycles to ensure a representative sample. Step 4. Rate the operator's pace against standard performance. An average motivated worker at natural pace rates 100%. Step 5. Calculate normal time by adjusting observed time with the performance rating factor. Step 6. Add scientifically determined allowances to arrive at the final standard time. Work sampling is a statistical technique involving random observations over extended periods. At each observation, we record the activity being performed. The percentage of observations provides statistically valid time estimates. This technique is particularly useful for long-cycle or irregular tasks and for determining allowances for indirect labor. Predetermined motion time systems like MTM break tasks into basic human motions, each with pre-assigned time values. Any manual task becomes a sequence of basic motions. By summing their time values, we determine standard time without a stopwatch. A key advantage is setting time standards before processes are implemented, aiding in product design and process planning. Method study is the systematic examination of existing and proposed ways of doing work to develop more effective methods and reduce costs. While work measurement quantifies time, method study optimizes the work content itself. It's about improving processes and procedures. Method study follows the systematic SREDIM process, 6 logical steps ensuring thorough investigation. Select. Choose work based on economic factors like high costs, technical factors like bottlenecks, or human factors like safety risks. Record. Document all relevant facts using appropriate charting techniques, process charts, flow diagrams, and string diagrams. Examine. Critically examine recorded facts using structured questioning. For each activity, ask what, where, when, who, how, and most importantly, why. Develop. Create the most practical, economic, and effective method based on examination insights. Install. Implement the new method as standard practice with proper change management and comprehensive training. Maintain. Conduct regular checks to sustain benefits and prevent reversion to old habits. Outline process charts show only main operations and inspections, providing a high-level view of the process. Flow process charts provide detailed breakdowns using 5 symbols, capturing every aspect of the process flow. Two-handed process charts analyze the work of both hands, identifying opportunities for better coordination and efficiency. Flow diagrams trace movement paths on layout drawings, while string diagrams use actual string to measure travel distances. Work study combines method study and work measurement in powerful synergy. Method study improves how work is done. Work measurement determines the time it should take. This combination creates a systematic approach to productivity improvement that addresses both effectiveness and efficiency. Method study attacks root causes of inefficiency, eliminating unnecessary operations, reducing travel distances, simplifying complex tasks, and improving workplace ergonomics. The result is a streamlined process requiring less effort, time, and resources while producing equal or greater output. Work measurement provides standard time, critical management information enabling effective planning, scheduling, and capacity assessment. Standard times are fundamental for accurate costing, budgeting, and pricing decisions. They provide objective benchmarks for measuring and managing individual and team performance, and they form the equitable basis for designing wage incentive schemes that reward superior performance. Let's solve a practical time study problem. An industrial engineer studied a manual assembly operation over 5 cycles, recording times and performance ratings for 3 elements. Element 1 times 8, 9, 8, 10, 9 seconds at 90% performance. Element 2, 22, 24, 23, 22, 25 seconds at 100%. Element 3, 6, 5, 6, 5, 6 seconds at 110% performance. Total allowances are 15%. First, calculate average observed time for each element. Element 1, 44 divided by 5 equals 8.8 seconds. Element 2, 116 divided by 5 equals 23.2 seconds. Element 3, 28 divided by 5 equals 5.6 seconds. Next, calculate normal time by multiplying observed time by performance rating. Element 1, 8.8 times 0.90 equals 7.92 seconds. Element 2, 23.2 times 1.00 equals 23.20 seconds. Element 3, 5.6 times 1.10 equals 6.16 seconds. Total normal time is 7.92 plus 23.20 plus 6.16 equals 37.28 seconds. Finally, calculate standard time by multiplying normal time by 1 plus allowances. 37.28 times 1.15 equals 42.87 seconds. This gives us a scientifically determined standard time of 42.87 seconds for this assembly operation. Now let's apply method study principles. In an e-commerce fulfillment center, workers spend excessive time walking long distances. Items are currently stored alphabetically. Solution 1. Implement ABC analysis. Place high-volume A items closest to dispatch, moderate B items in middle zones, and low-volume C items furthest away. Solution 2. Implement batch picking. Workers collect items for multiple orders in single trips, dramatically reducing travel time per order. Solution 3. Optimize slotting by placing frequently co-purchased items in adjacent locations, reducing travel between consecutive picks. Incentive schemes link employee earnings directly to performance measures like output, efficiency, quality, or cost savings. The purpose is motivating employees to perform above standard levels by sharing productivity gains, aligning worker interests with organizational goals. Individual incentive schemes base rewards on single employee performance. The straight piece rate system pays a fixed amount per unit produced. Time-based systems like Halsey and Rowan Plans guarantee base wages plus bonuses for completing jobs faster than standard time. The Halsey plan gives workers a fixed percentage, typically 33 to 50%, of the value of time saved, sharing gains between worker and company. The Rowan plan calculates bonus as proportion of time saved to standard time, offering high initial incentives but diminishing returns at maximum efficiency. Group incentive schemes base rewards on collective performance when individual contributions are difficult to isolate or teamwork is critical. Profit sharing distributes portions of company profits to employees, while gain sharing rewards improvements in operational metrics. The Scanlon plan, a popular gain sharing approach, rewards reductions in labor costs or material usage relative to historical baselines. Let's solve an incentive problem. Standard time is 8 hours. A worker completes the job in 6 hours. Hourly rate is Rs 100. Time saved is 2 hours. Under straight piece rate, standard earnings are 8 times 100 equals Rs 800. The worker earns Rs 800 regardless of actual time taken. Under Halsey plan with 50% sharing, base earnings are 6 times 100 equals Rs 600. Bonus is 50% of 200 equals Rs 100. Total earnings Rs 700. Under Rowan plan, base earnings Rs 600. Bonus is 2 divided by 8 times 6 times 100 equals Rs 150. Total earnings Rs 750. Comparison shows piece rate provides highest earnings, followed by Rowan, then Halsey, each with different motivational characteristics. Job evaluation systematically analyzes job content to determine relative worth within an organization, creating rational wage structures. Critically important, job evaluation assesses the job, not the person. It analyzes roles based on skill requirements, effort, responsibility, and working conditions. The outcome is internal equity, ensuring jobs of greater organizational value receive proportionally higher compensation. The ranking method is simplest. Evaluators rank all jobs from highest to lowest in perceived organizational importance. Job classification assigns positions to predefined grades based on complexity and responsibility descriptions, common in public sector. The point method is most widely used. Compensable factors like education, complexity, and responsibility are defined with degrees and point values. Jobs are evaluated and scored. Performance appraisal systematically evaluates individual employee performance against predefined standards. Unlike job evaluation, this focuses on the person. Performance appraisal serves dual objectives: administrative decisions like promotions and pay increases, and developmental goals like identifying training needs. Graphic rating scales. Rate employees on numerical or descriptive scales for traits like work quality, quantity, knowledge, and initiative. Management by objectives involves collaborative goal setting. Manager and employee jointly establish specific, measurable, achievable, relevant, time-bound objectives. 360-degree feedback collects performance input from multiple sources: supervisors, peers, subordinates, even customers, providing holistic perspective. Behaviorally anchored rating scales combine graphic scales with specific behavioral examples, making ratings more objective and reliable. Let's distinguish critical concepts. Work measurement determines time required for tasks, while method study improves how tasks are performed. They work in sequence and synergy. Job evaluation assesses job content and relative worth, while performance appraisal evaluates individual employee performance. One focuses on the role, the other on the person. Industrial engineering principles apply across industries. In healthcare, optimizing patient flow, improving surgical scheduling, and streamlining pharmacy operations. In services, banking process optimization, call center efficiency improvements, and restaurant service streamlining all benefit from IE principles. Modern IE integrates IoT sensors, real-time analytics, and automation to continuously monitor and optimize operations. Successful IE implementation requires strong change management. Clear communication, stakeholder buy-in, and comprehensive training are essential. Foster a continuous improvement culture where employees actively identify and suggest process enhancements. Establish robust measurement systems to monitor progress and ensure sustained improvements. You now possess a comprehensive industrial engineering framework. Work study eliminates waste and optimizes processes. Incentive schemes motivate performance. Job evaluation ensures fair compensation. Performance appraisal drives individual excellence. As a manufacturing manager, you can now systematically analyze any operation, identify improvement opportunities, and implement sustainable solutions. The future of industrial engineering embraces Industry 4.0 technologies. AI-driven optimization, predictive analytics, and smart manufacturing systems amplify traditional IE principles. Sustainability becomes increasingly critical. IE principles drive resource efficiency, waste elimination, and environmental responsibility. Global supply chains require sophisticated IE applications for resilience, efficiency, and responsiveness. Your immediate action plan. First, assess current operations using the 8 wastes framework. Second, prioritize improvement opportunities based on impact and feasibility. Third, develop your team's IE capabilities through training and hands-on application. Fourth, establish measurement systems to track progress. Fifth, create a culture of continuous improvement where IE principles become embedded in daily operations. Congratulations! You've completed the comprehensive Industrial Engineering and Productivity Masterclass. You now have the knowledge and tools to transform manufacturing operations. Remember, industrial engineering is both science and art. Apply these principles systematically, but adapt them creatively to your unique challenges. The future of manufacturing depends on leaders like you who understand that true competitive advantage comes from operational excellence. Go forth and engineer efficiency, productivity, and quality into every aspect of your operations. Your journey to manufacturing excellence starts now. Apply these principles, measure your results, and continuously improve. Thank you for joining this masterclass.